Okay, so let's move on to the next topic now, precision versus accuracy. Right? So let's define it, and you guys may be familiar with this already. Let's define it. Accuracy refers to how close the measured value is to the actual value, and precision refers to how close a series of measurements are to one another, or how reproducible they are. Okay. So if you take a look at the series of data, um, student A, B, and C, they were tasked with weighing a lead block, and its true mass is 10.00 grams, right? And so the test was to see, how well the students were able to weigh a lead block. So we can see that each student got 4 trials to weigh the lead block, and here's the result, right? So we can ask, right, which student is the most accurate and which one is the most precise, okay? So the answer here would be, well, let's look at the average. The true mass should be 10. So we can actually see that student C did really well, right? All their trials are close to 10, which is the true mass. So they have accuracy, right? And they also have precision because all the numbers are really close to each other, right? So that's what precision is. Precision is how consistent they are. Accuracy is how close are they to the target, right? So to student C is both precise and accurate. And we can judge that, student B, right? Let's see how student B did. Student B's number is pretty similar to each other. So they have consistency, meaning they have precision. But the problem with student B is they didn't have accuracy, right? So oftentimes, when you're doing science, that's how it is, right? Of course, we want to strive to be student C. We want to be both precise and accurate, but sometimes we get like student B, right? We're precise, but we're not accurate. And we really don't want to be student A. Student A is all over the place, right? Neither precise nor accurate. So at least with student B, we're like, oh, look, student B is always below 10. So let's see what is going on. Maybe their scale is an issue, right? And so when you have student B, erring like student B is easier to fix than erring like student A, right? If you make errors, you'd rather be like student B. When you graph their results too, you can see that, right? You can see that student C, both accurate and precise. Student B is precise but not accurate because they're consistently below 10. Right? And then student A is just quite random, right? Both inaccurate and imprecise. So that leads us to what's called random error and systematic error, right? So random error is an error that has equal probability of being too high or too low. So the results of student A are both inaccurate and imprecise. So that leads to what we call random error. We don't even know how to fix it, right? Because we don't even know where to start, right? It just seems like very random. Now, systematic error is a better error to have because at least we know how to fix it, right? We know in which way we can fix it. So student B was precise but inaccurate, and they were always lower, right? Their results were always too low. So we're like, okay, at least we know how to fix that, right? Okay.